Hi everybody, my name is Peter Atkinson. I'm making this video to tell you about my theory of gravity. Gravity has been discussed and studied for thousands of years, but to date there's only three famous people which have worked on gravity. That's Galileo, Einstein and Newton, and only one of them made a theory which is accepted today, and that is Einstein's theory of curved space-time as the cause of gravity. Newton came up with very accurate equations, but he never came up with a theory. And Einstein came up with a theory and equations which are slightly more accurate than Newton's. I'm going to start off discussing Galileo's famous experiments, because this laid the basis for gravity studies. Now, with a thought experiment, he worked out that Aristotle's claim that heavier, bigger objects fall faster, he worked out with a thought experiment, similar to the type of experiment that Einstein did, that it could not be correct. Because he argued that if you take a heavy body and a light body, and you join the two together, then the combined mass should make the object fall faster. However, because you've got a lighter body attached to a heavier one, the lighter one should make the combination fall slower. So there's obviously a problem, and he worked out that the explanation must be that they're falling at the same speed. So he derived experiments to prove this, and in 1633 he did his famous experiments to show what gravity was. Now, it's said that he did the experiments from the Leaning Tower of Pisa. Other people said it wasn't true, and that he used ramps to do the experiments. He didn't use cannonballs falling off the tower, any of those other stories. Be that as it may, he showed conclusively that all objects fall at the same speed. And it doesn't matter whether it's made of gold or made of sand or steel. It doesn't matter what the shape is or what the object is at all. It makes absolutely no difference. Everything falls at the same speed. The fact that all objects fall at the same speed was proved dramatically in one of the Apollo missions, when James Scott and Irwin, the other astronaut, they dropped a heavy prospector's pickaxe and a feather which had been taken to the moon precisely for this purpose at the same time. And as was expected, both the hammer and the feather hit the ground at exactly the same time. Now, if you didn't know this, I'm sure you're not alone. I think at least half the world's population don't know this, even though it was shown hundreds of years ago that this was the fact, because it's so counterintuitive. And then I tried to work it out myself when I was at school to find out why this happens, and I came to the conclusion, and I'm sure that I was right then and right now, that the reason for this is that everything is made of the same subatomic particles. These subatomic particles were created in the Big Bang, and it's quite a concept to think that everything is made of the same particles, and that they've existed for 14 or more billion years in an unchanged state. It is quite a concept to think about it. Your body is made up of subatomic particles which were created in the Big Bang 14 billion years ago. And these subatomic particles are the same for everything. So everything is made of the same type of subatomic particles. The ones we know about, everybody knows about, is protons, neutrons, electrons. But these in turn are made of other subatomic particles which mainly are quarks. And there's a whole zoo of subatomic particles. Now, the concept is that gravity acts on these subatomic particles. And when you're thinking of gravity, you've got to stop thinking about objects like this mug of coffee, which I'm busy drinking. You must think of this as trillions and trillions and trillions of subatomic particles. All these are quarks and bosons and all the rest of them. Now, the gravity is acting on all of those objects. That is why everything falls at the same speed. The gravitational force per subatomic particle is the same in all of everything which exists. And the acceleration is therefore going to be the same, and therefore the feather and the pickaxe hit the moon's surface at the same time, because the acceleration was the same on all these subatomic particles. And that is why everything falls at the same speed. So that brings me into the next subject I want to talk about, which is the nature of matter. Now, most of the people were thrown out who worked out their gravity theories by this very fact. They thought that solid objects are solid, and seeing is believing. In fact, it isn't true. Seeing is not believing. Matter is mostly empty space. In 1889, Ernest Rutherford, who was a New Zealand physicist working in England, did a series of experiments to show the nature of matter. He shot alpha particles at a gold foil and measured the angle of deflection. He was expecting the particles to be deflected from the going through the gold foil, but what he found was that some of the particles were bounced right back at him. So from this he deduced that matter has a nucleus, the atom has a nucleus right at the center, and there's electrons orbiting around the nucleus, and that was the model he came up with, and everything to date has proved that that is correct. Now, some clever people have done analogies to bring it into a human scale. So one that I like the best is that if you take St. Paul's Cathedral, which is really quite a huge place, the nucleus of the atom will be about the size of a walnut, and the electron will be flying around the edges of the cathedral about the size of a small fly. So that puts it onto a scale. So in fact, most of matter is completely empty space. Well, actually it's not empty, as I'll show you later, it's full of ether, but it's basically empty space. And that's with normal matter as it exists on Earth. Matter doesn't only exist in this form, it exists in other forms. When a supernova explosion occurs, the center of the star condenses into a very, very small space. So the whole mass of the star condenses down into an object about the size of the Earth. And on that same scale, the Earth, the entire Earth, could fit into the size of a bowling ball. So when you see a solid object, it's not solid. It's actually not solid at all. It's just a few tiny, tiny specks of matter in a vast empty space. And this is where Einstein made his huge mistake, which I'm going to talk about later, thinking that because an object looks solid, it is solid, and it isn't correct. And that's where he went wrong and misled the entire world for 100 years after that. The next thing I need to talk about is the nature of light, because it was during the investigation of the nature of light that the big mistakes were made, which led to the incorrect theory of gravity which we've got today. The first theory of the nature of light with substance was proposed by René Descartes in 1637, and he proposed that light moves as a wave, and he used this idea of a wave to explain the refraction of light. So that was quite a good theory. Later in 1690, Huygens wrote a series of papers about the nature of light and the bending of light, and he also came to the conclusion that light must be a wave. And it was then proposed that there must be a medium through which this light moves, and that was then taken to be the ether. Now, it was known that a wave propagates through a medium. In the case of sound, the medium can be air or it can be water, and a vibration can travel through the ground or it can travel through steel, and it is also known that the denser the medium, the faster the wave travelled. So it was proposed that the medium through which light travels is the ether. Now the ether has been around for centuries, so you can consider it as very, very small particles, very, very tiny particles packed closely together. It's a bit like a gas in relation to us. We in relation to the air particles, air molecules would be about the same as an air molecule in relation to the ether. So it's very, very, very tiny particles. And they calculated that this would have to be very dense for light to travel at that speed. Now, in Newton's time, it was considered that light was a wave travelling through the ether. Then Newton wasn't so sure about this. So in the beginning of his career he believed in the ether. Later on he believed that light was a particle, which he called a corpuscle. So he wasn't happy that light was a wave. So in one of his papers he mentioned that light is probably a particle and it's surrounded by a wave. And I think that's exactly what it is. And I think he was right there, but he never pursued that. And from his time right up until Einstein's time, which was 300 years, it was believed that light is a wave travelling through the ether. And not just a wave, but a compression type wave. So that's what they had. And then when Einstein came along, he turned the whole thing upside down. Now everybody was happy that light had to be a wave because it explained very nicely refraction and diffraction, the colour of light, and it explained interference patterns, explained everything that you could want to explain. Now when Einstein was a young man, he was doing work on the photoelectric effect. And it basically showed that when you take a light of high energy, like ultraviolet light or blue light, and shone it onto a metal surface, it would knock off electrons. And what people don't know is that he won his Nobel Prize for this work, not for his later work on the theory of relativity, but he actually won the prize for the photoelectric effect. And from his work and from other people's work at the same time, there was a feeling was growing that these results were due to the fact that light was a particle and not a wave. So the black body radiation, Einstein's experiments with the photoelectric effect and other experiments too showed strongly that light must be a particle. And so there was a big problem. The theory was that light was a wave, and the new evidence coming out from Einstein and the other workers was that it was a particle. So there was a conference called later in Stockholm when they said light is both a wave and a particle. And that didn't please Einstein. It certainly didn't please a lot of scientists, but that was what was put out, and that held a peace for a long period of time. Other scientists previously had also had problems with the duality of the nature of light. In 1675, Newton wrote a book in which he said the forces between objects were mediated by the ether. But later on in his life he said the ether didn't exist, because if it did, it would slow the earth down. And clearly the earth doesn't slow down, therefore the ether couldn't exist. And that his corpuscular theory of light must be correct. Einstein used almost exactly the same argument. He said that the ether didn't exist because it would slow the earth down as it orbited the sun, and clearly that doesn't happen. Therefore he also, exactly the same as Newton, said the ether can't exist or it would slow the earth down. And that his theory, which Einstein called the particles photons, whereas Isaac Newton had called the particles corpuscles. He said that the only thing which is necessary to explain the light is that they are particles, and the ether didn't exist. So both Einstein and Newton made firm statements that the ether didn't exist, and I think this is where the big mistake was made. Now, it was quite controversial, so an experiment was formed to show whether the ether existed or not, and this was the famous Michelson and Morley experiments. These were two physicists working in San Francisco, and they made an experiment to show whether the ether existed or not. Basically that was what it was. Okay, the next thing I want to talk about is the phenomenon of stellar aberration. If you've not heard about this, you're not alone, because not many people know about it. But from this talk, it's actually quite important. Okay, the whole story started in 1543 when Copernicus gave his theory that the sun is at the center of the solar system and the planets move around it. Then in 1619, Kepler put more meat on the bone when he worked out his detailed orbits of the planets and gave the mathematical equation which is still used today. He basically said that the planets move in ellipses around the sun, with the sun at the one end of the ellipse. And everybody said, well, that's great, it works fine, it looks good, but prove it. And then they thought this will be easy because they can just use parallax to prove it. But it turned out to be a lot more difficult than that. Basically, parallax is a fairly simple thing. When you move in one direction, other objects seem to move in another direction. So if you're in a motor car and you're moving forwards, the things close to you like street signs and trees will move backwards quite quickly, but distant things like mountains, they'll also move backward very slowly. So basically, if you know how far you've gone in one direction and how far the other object has moved backwards, then you can calculate with simple trigonometry the distance from you to that other object. So Bradley said, well, we can do this. We can use parallax to prove Kepler's equations. So what he did was he mounted a telescope rigidly to his house in London, in Kew, and pointed it at the star Gamma Draconis. Now Gamma Draconis is a fairly bright star which in a certain time in England is directly overhead in London. So he needed to fix it to his house because he needed to make observations for a year. So he did this, and when he looked at the Draconis, he noticed that he expected the image of the star to move backwards to be able to measure the parallax, but it didn't move backwards, it actually moved forwards. And they did the same experiment with the Polaris star, and they found the same thing, that instead of going backwards like they expected, it actually moved forwards. So they couldn't understand this, and that's why they called it stellar aberration. So Bradley worked out an explanation for this. The Earth is moving in the one direction, and the light is coming in another direction, and it forms a small angle, and that's what causes this phenomena, and that's why they call it stellar aberration. Now Bradley was a very bright guy, well most astronomers are, and he worked out that if you know the speed of the Earth, which he did know, and you know the angle, which he also knew, which is very small but measurable, then he could work out the speed of light, which he did, and he came to the figure of 186,000 miles per second. Now, several years earlier, another astronomer, Romer, had worked out the speed of light by studying the moons of Jupiter, and he came to the conclusion that light was 186,000 miles per second, the same as Bradley. And he realized that the other stars near Gamma Draconis were showing the same deflection. So they had the light coming from those other stars was going at the same speed, and it didn't matter how far they were away, how dim they were, or what color they were. The angle was the same. So he came to the conclusion that the speed of light is a constant. So it wasn't Einstein who said that, it was first James Bradley who said the speed of light is a constant. And then he also said something else which was quite important. He said that if the speed of light is a constant, it's not likely to be called Newton's corpuscles, because you'd expect them to be moving at different speeds. You know, some would be fast and some would be slow, depending on the color or the distance of the stars. But the fact that they're all the same would suggest strongly that there's actually a wave moving through a medium which he called the luminiferous ether. So he was in favor of the ether theory. Many years ago, when I was a young guy, I was landing at Heathrow Airport, and the plane was circling the airport, and it was raining like it's always raining at Heathrow. And I noticed that the rain was almost parallel to the wing of the plane. And knowing about stellar aberration, I thought maybe I can calculate the speed the rain is falling. So I did a similar calculation to Bradley. The angle of the rain I estimated was about 10 degrees, and I estimated the plane was doing about 200 miles per hour. And after a little bit of calculations, I worked out that the rain was falling at 35 miles an hour. I doubt whether I could do that calculation today with my fossilized brain. The other conclusion that James Bradley came to was that the stars are very far away, because he couldn't demonstrate parallax. So to put this on a scale, if you were in New York and our sun was the diameter of a ping pong ball, then the nearest star would be another ping pong ball in Hawaii. So that's the scale we're talking about. The universe is almost completely empty. Well, it's not empty, it's full of ether, but besides that, it's completely empty. And then that caused a big riot, because a lot of people had said, well, you know, what about the deflection that you should expect to get from ether? Because it was thought at that time that the ether is static, and the Earth is moving through the static ether. And as you move through the static ether, there should be a deflection, because the ether is going to affect the light. And he couldn't demonstrate any deflection. So this caused a big controversy, and they said, well, this probably the explanation is that the ether is being dragged around the solar system by the Earth. So it's like stirring a cup of tea. As you start stirring the tea, initially the tea is static, but later on the tea moves at the same speed as your teaspoon. And they thought that that's what's happening, that the Earth is dragging the ether around with it, and that's why you're not getting a deflection. And other people suggested maybe what's happening is that the ether is all inside the Earth, and the Earth is capturing all the ether inside it. And there was a lot of confusion. And later this led to an experiment to find out what the real truth is. Almost 150 years later, Michelson and Morley had invented a interferometer. They could measure the speed of light very accurately by bouncing light off mirrors at right angles, and that produced an interference pattern. And this machine was so precise that they could actually measure the difference in the speed of light in different directions. So they then went about seeing if the ether existed or not. They said if the ether exists, then in one direction you're going to get the light moving faster than in the other direction. So they used this instrument and they found no difference. Then they said, well, maybe it's because the ether is being dragged around by the Earth, and maybe if we go to the top of a high mountain, we'll find a difference. So they went to the top of a high mountain, a lot of work to do that, found no difference. They then rebuilt their machine using a more sturdy stone bed, and they got the same result. They could not demonstrate any difference in the speed of light, no matter what they did, what direction they put the machine in, it always gave the same result. And then a German physicist Juster in Germany, he built another machine, a better one, and he also came to the same conclusion that there was no difference in the speed of light, no matter where you point your machine. So this was really an unexpected result, because everybody at that time was thinking, well, they'll be able to demonstrate the difference in the speed because the ether exists. So that was a big problem for the James Bradley group of people. I mean, the people who believed in the ether, this was a big problem. And so then Einstein came along and he said, well, the explanation is obvious. You know, there is no ether. But Einstein went further. He said, you've proved that the speed of light is a constant. We don't need the ether. The speed of light is a constant. So taking that figure, that the speed of light is a constant, he then got his equation E equals mc squared, and he then did his whole theory of relativity, and he became the most famous scientist in the world because of his theory of relativity, which basically says that the speed of light is a constant, and that because of that light, because the light is a constant, other things change, time changes, and people at that stage, of course, didn't believe it. You know, there's no way to prove that time changes. It's now known for certain that time does change. In a gravitational field, time changes, and every finding of every experiment done since 1905, when Einstein released his book, every experiment done has proved that his equations are correct. But the problem is that he made the statement at the same time that the ether doesn't exist, and that's where the big problem started, because I believe that he was wrong and that James Bradley was correct, that the ether does exist. Where he made his mistake was he fell into the old trap of seeing is believing. He saw that the earth is a solid. Therefore, like a ship travelling through water, is going to have a compression wave on the one side. Where the ship moves forward, the water will be compressed and it will rise up in a heap, and you'll have compression. But he was not correct. First of all, the earth is not solid. It's almost completely empty space. Well, actually filled with ether, but it's completely empty. The second thing is he never realized that ether is completely frictionless. There is no friction involved with the ether. That's why, first of all, it goes through the earth because the earth is empty. And then the second is where there is a little bit of matter, it doesn't matter at all because the ether is completely frictionless. It's only accelerating ether which can exert a force. And so that's why the earth goes right through the ether and it doesn't affect it at all. And that's where he made his big mistake. Because once he said there's no ether, that put the whole world in the wrong direction for 100 years. A huge mess. That's what he made. And Bon Jovi wrote a song about it, you know. Shot through the heart and you're to blame. You gave ether a bad name. The findings of Joster in Germany are very important, I think, because once you have a finding confirmed by more than one scientist using different instruments, especially in different countries, then you know you've got something which is real. And that's really important in science, to know that you can rely on your results. Okay, so I've accepted that the ether does exist, and these are the principles of ether dynamics which I've come up with. Okay, the first one is that objects moving at a constant speed through the ether, whether in a straight line or in a regular curved motion, such as a circle, will exert no force on the ether and will move through it in a frictionless manner. And the ether, in turn, will exert no force on the object. So the motion is entirely frictionless. The next principle is that an accelerating ether flow will exert a force on all objects in that accelerating ether flow. And the force will be in the same direction as the accelerating ether flow. Okay, the next point is that ether is destroyed in all matter at a constant rate, according to the number of subatomic particles in the matter. The destruction of the ether in an object is proportional to the mass of the object. The next point is that ether cannot enter into the interior of subatomic particles except to the extent that they are destroyed by those particles. The next point is that the mass of an object is equal to the number of ether particles displaced by that object. The next point is that ether will move from a region of high density to a region of low density until the ether pressure is normalized. Over the entire universe, the ether pressure is eventually normalized until it becomes a constant. Gravity is caused by the flow of ether from a region of high ether pressure to a region of low ether pressure. The ether is accelerated during this process. The ether's pressure is higher further away from the object and lower closer to the object. This is because the ether is being destroyed by the object.
Yeah.
The next point is that a compression wave can travel through the ether. The speed of the compression wave traveling through the ether is proportional to the density of the ether. The density of the ether limits the speed of the compression wave through the ether, and this limits the speed of any object traveling through the ether. The speed of light is a constant because the density of the ether is generally a constant. I just want to discuss a few of these points in a little bit more detail. The first one to discuss is that an object moves through the ether in a frictionless manner. So when it's moving in a straight line or in orbit, as long as the velocity is not changing, there will be no frictionless. It's a frictionless environment. So how do I know that this is correct? Well, Michelson and Morley's experiment showed that that was the case, that the ether went right through the Earth with no effect on the Earth at all. And this is where Einstein made his big mistake. He didn't realize that this is a completely frictionless environment, and it's because it's completely frictionless that they got a negative result in the experiments. Now, the ether will only affect an item or an object if the ether is accelerating. So the critical thing to remember is it has to be accelerating. Remember Newton's first law? An object will be accelerated if there's a force acting on it. F equals ma. So in the case of ether, there's no acceleration, there's no force. The next point I want to discuss is the accelerating ether flow. Now, ether can be accelerated for a very short period of time. For instance, if you fire a gun, as the bullet accelerates, the ether will be accelerated as well. We'll discuss that a bit further later on. But that's a temporary and very short-lived acceleration of the ether. On the other hand, ether can also be long-lived. For millions of years you can have a stable accelerating ether flow, and this is what gravity really is. So let me just go into a bit more detail about what gravity is as I see it. So the Earth is destroying ether, and the ether pressure inside the Earth is much lower than outside. As you go into space, that pressure is higher because it's not being destroyed there. So it goes from a high pressure area into a low pressure area. So the ether rushes into the Earth. And as it gets closer to the Earth, it's accelerated. The ether is accelerated so that the pressure can remain the same. And that accelerating ether exerts a force, and that's the force of gravity. So you are not attracted to the Earth. You are pushed onto the Earth by the accelerating ether flow as it goes into the Earth. Because the mass of the Earth hasn't changed for millions of years, that ether flow is stable. And that's why you get all the orbits of the planets, which can be worked out and calculated with great accuracy, because it's a stable ether flow. Okay, now I said that in my theory the ether is destroyed. And that's an important statement, if it's correct. I thought it had to be destroyed, otherwise the mass of the atoms would increase. And there's no evidence that atoms are getting bigger. So the evidence it suggests that the ether is being totally destroyed as it goes into the object, into the Earth or any other object. Now how can that possibly be true? How can something just disappear completely from the universe? How can it just disappear? Well, the answer is we don't know. The human brain is too small to really work out how this is actually possible. But remember that the universe came from nothing. It just popped into existence in the Big Bang. If the Big Bang theory is correct, which I think it is, it just popped out of nowhere, and we can't understand where that could have come from either. Religious people say, well, there's God and everything, but that doesn't make any sense either, because then where did God come from? The answer is nobody knows. We haven't got the foggiest notion of where the universe came from, or even why it came. We've got no idea. So if we don't know where it came from, and it just popped into existence, it's not so radical to say that ether can just disappear from the universe. And in fact, it may be a natural cycle, that it appears and then it disappears, and eventually you ended up with nothing at all. The ether gets destroyed and everything else will also just disappear from existence. It's a hard notion to understand, but it could be true, and that would be the cause of gravity, would be fundamentally that the ether is being destroyed, and the ether makes up most of the universe. So the universe is gradually being destroyed, and eventually everything will be gone. A bit depressing. The next point I want to discuss is the origin of mass. Now, in my theory, mass is due to displacement of ether by subatomic particles. Now, thousands of years ago, Archimedes showed that a floating ship displaces its own mass of water in which it floats. So that's where I got the idea that the mass can be due to the displacement of ether. And the more I thought about it, the more it makes sense, because you can explain a lot of things like using that idea, so that more massive objects are displacing more ether. So if you need to get them to move, you're going to need more ether to get it to move, or to accelerate. You're going to need more accelerating ether. So that's where I thought that made sense. So to have this happening, you have to have a limitation on how much ether can go into an object, otherwise it's going to have no mass. So then what I think is happening is that most of the ether, in fact all of it, nearly all of it, is excluded from the subatomic particles, but some of it, a small amount, gets into the subatomic particles where it is annihilated and disappears. And so it's displacing most of the ether, but not all of it. So the question has been raised of, why is the speed of light a constant? Why actually is it a constant? Well, one possible explanation is that the photons are produced in only one manner. So at some fundamental point, the photon is produced and released, and at a constant speed, which is the speed of light. So an analogy would be that there's only one factory in the world manufacturing guns. For instance, say a Colt 45. There's only one gun available, that Colt 45, and there's only one ammunition, and that's also the Colt 45, made in the same factory. So if you were to be measuring the speed of a bullet close to a gun, you would come to the conclusion that the speed of bullets is a constant. right? So if the mechanism of production of a photon is fixed and there's only one possible way a photon can be made, that could be an explanation of why the speed of light is a constant. The other explanation for the speed of light being a constant is that it's moving through a medium, and the medium being the ether. So what happens is, as the photon moves through the ether, it pushes the ether in front of it away, and then the ether goes around behind the photon and then pushes it from behind. So the net result is that there's no friction, but as it moves the ether away, there's a transient compression wave surrounding that movement. And that compression wave is important because that causes all the phenomenon that you see, like refraction, diffraction, interference patterns, and all of those things. Those are caused by the compression wave surrounding the photon. But in free space, that's not going to have any effect at all, because the ether will equilibrate back to the same pressure within a very short period of time. But when it's near an object, that's a different story, because that compression wave will hit another bigger object like a neutron or a proton or whatever it is, and then that atom will then go into motion, and then there's less energy coming back to the photon from the one side, and that's why the photons will bend around a big object, because the compression wave goes out, it hits the proton or whatever, and it starts the proton moving, and then the ether can't come back again. But from the other side it does come back. So the net result is that there's a force on the photon from the opposite side. So if it goes past a neutron, it will bend around the neutron, and that's the reason that you get, straight edge refraction, is because the light is bending around the solid object. So that's why they put, for instance, lead into glass, so that as the photons go through the glass, they bend towards the large nucleon, and so that bends towards the gold atom, or any heavy atom like a lead atom. The light will bend towards it, because for a short period of time, the ether pressure is not the same. It's lower on the side towards the big atom. So that's the reason why the speed of light is a constant, because there's a transient compression wave surrounding the photon, and the compression wave travels at a fixed speed. So it's like air. Air travels at 1,000, sound travels through air at 1,000 miles an hour, and photons travel through ether at the speed of light, and that light is dictated by the density of the ether. If you reduce the density to the ether, the light will change it in that point. And generally it's impossible to do that for a long period of time. Okay, I want to discuss another thing, which is what happens when an object accelerates into the ether. Well, let's take an example of a rocket motor. A rocket, as the fuel ignites, the molecules expand at a rapid rate and they accelerate, and as those gas molecules accelerate into the ether, they cause the ether to be compressed. The accelerating object causes a compression of the ether. The ether compresses, and that compression of the ether causes the molecules to start to pile up. And as those molecules pile up and the density of those molecules increases, because of the ether resistance, it exerts a force on the actual rocket itself. So the gas goes into space, causes compression of the ether, and that in turn causes the rocket to go forward in the other direction, which is the explanation of Newton's third law. For every action there's an equal and opposite reaction. If there was no ether, then the molecules from the engine would just shoot off into space and the rocket would stay exactly where it is. It's the presence of the ether compressing which causes the reaction. And if there was no ether, there'd be no compression, there'd be no reaction. Okay, well, Newton's theory, basically he said that gravity is due to a force directed towards the center of the object. So if you're standing on Earth, you're attracted to the Earth, and the attraction is directed to the center of the Earth. So Einstein had a problem with that theory, because if it's an attraction, you have a problem, because if you want to, for instance, you're on the Earth and you want to attract the Moon, you have to send a message to the Moon that, hi, I'm here, and you've got to find out where the Moon is, you have to have a two-way transmission to get the information. So it goes to the moon and then comes back to the Earth and says, the moon is there. The problem is when you go there, try to grab the moon, it's gone already, it's in a different position. So you can't understand how gravity could possibly be an attraction. And Einstein realized that, and he said that this is impossible. And he called it spooky action at a distance. And he said it's just impossible. So then he derived his equation of gravity, which is caused by curved space-time. In other words, space-time bends, and that causes gravity. And to believe that, you have to understand his concept of space-time. And that is a little bit beyond this talk here because it's very complicated, the mathematics, etc. But basically, he says that space bends, and the bending of space causes gravity. That's his theory. But with his theory, it overcame the problem of Newton's theory, in that he realized that it can't be an attraction. So his space-time thing is more similar to my theory, that the bending of space-time is causing the gravity. So that does away with the problem that Newton's theory has. And but my theory gets around the problem of Einstein's theory, which is actually what is really going on when you bend space-time. It seems very vague and hard to understand. It's much clearer to understand that you've got particles going through you and into the Earth, accelerating, and those accelerating particles are dragging you with it. So gravity is really a drag force, and it's much easier to understand that than Einstein's theory. You have to understand where Einstein was coming from. At the time of Einstein's theories, they didn't even know about galaxies. Galaxies were only discovered years after his theories were published. So there was very little information about the universe available to Einstein. So with the information he had, he did a very good job. And people didn't believe his theories of relativity, time changes and all of that stuff. But now it's been proved conclusively that his theory is correct. Not his theory, his equations are correct. You know, the equations that he had for gravity are correct. But the theory is unfortunately wrong, in my opinion. It took 300 years from the time that Kepler gave his equations for the orbit of the Earth around the Sun for anybody to prove that the Earth is actually moving. And they certainly didn't know the distances of stars until the beginning of the 20th century. So how was this done? Well, the close stars were measured by parallax using very large telescopes. And then using parallax, they measured the distance to the Cepheid variables, and then they got the relationship to the speed of the rotation to the distance. And then they used Cepheid variables to prove that the redshift can be used to measure the distance of stars. So parallax proved Cepheid variables were valid, and Cepheid variables proved that the redshift was valid. So then they had a method of measuring galaxies, the distances of galaxies. And Hubble found, when he plotted the distances of galaxies to the speed of the galaxy, that the further away they were, the faster they were moving away from the Earth. So he discovered the Hubble's law, which is that the speed of a recession of a galaxy is proportional to the distance of the galaxy. The further away it is, the faster it's going. Now they're all moving away from us except the very close ones. The very close ones around us, the Andromeda galaxy should be receding from us at 150 kilometers per second, but it's actually moving towards us. So the nearby galaxies, which are in clusters and groups, these laws don't apply. But once you're far out into the universe, then it does apply. Hubble's law has a constant in it, which is 72 kilometers per second per megaparsec. And a megaparsec is 3.2 million light years. Why did they use such a strange thing as a megaparsec? Well, I think that's the same as doctors. They want to use Latin phrases which mere mortals can't understand. I think astronomers are a bit like that. Now, working backwards to the origin of the Big Bang using Hubble's constants, it was calculated that the age of the universe was 14 billion years. Now, there's another thing you can do with Hubble's law, which is what I did, and that is to find out what point will the galaxies be receding from us at a speed more than the speed of light, which is 300,000 kilometers per second. So I did this calculation myself and I came up to the figure of 13 billion years. So at a distance of 13 billion years, the galaxies will be receding so fast from us that they'll be faster than the speed of light. That means that they'll become invisible. Okay, at this point I want to discuss Olber's paradox. Olber was an astronomer who lived, and in 1823 he published his paradox, which is basically that if the universe is infinite, then any direction you look in, you should come across a star. So at night, if the universe is infinite, the background sky should be bright, but in fact it's black. So Olber said, well, this would indicate that the universe is not infinite. That's why the sky is black. Of course, at that stage, they didn't know that the speed of light was a constant, and that everything is receding from us. So I think the explanation for Olber's paradox is that the universe is receding from us, and beyond a certain point we can't see anything because it's going too fast. And that's why the universe is black. And that explains Olber's paradox. The next point I want to discuss is the recession of the moon. Now in Apollo 11, 14 and 15, those astronauts took reflectors to the moon. And Russia had 2 unmanned probes went to the moon and also left reflectors there. One of them is working. What they found with those reflectors on the moon is that the moon is actually receding from the Earth at a speed of 2.9 centimeters per year. It doesn't sound a lot, but it is measurable. So those bouncing lasers off the moon have proved 2 things. They proved that the moon is moving away, but also importantly they proved that light is a particle, it's a photon. And the wave theory must be completely out, because you cannot possibly send a light beam to the moon and back without it dispersing so far. It would be completely unmeasurable. And so they know from the results of the laser reflectors that light must be particles. So Einstein must be correct that light is a photon. Now I wondered if the recession of the moon wasn't basically the same thing as the recession of the galaxies. So I applied Hubble's law to the recession of the moon, and you start off with huge figures, 10 to the power of 18, and then eventually end up in centimeters, not kilometers. So you start off with 10 to the 18 kilometers and you end up with centimeters. It's quite a complicated calculation, but I worked it out that the speed of the recession according to Hubble's law should be 2.13 centimeters per year. That is astoundingly close to what it really is. So I don't think it's an accident. I think it is the same phenomenon which is causing it. And the Earth then should be moving from the Sun. Some people have suggested it is, but I'm not sure that everything is correct there. But anyway, if the Earth is moving away from the Sun and it is obeying Hubble's law, then when 100 million years ago, in the age of the dinosaurs, the Earth would have been slightly closer to the Sun than it is today. Not a big difference. 150 million kilometers is the present distance. It would have been 148.8 million kilometers. That's a small difference due to the Hubble constant moving the Earth from the Sun, but it probably did occur. Now if you take the beginning of the solar system, which is 4 billion years away, not 100 million, that difference becomes much bigger. And in fact it would apply to all the planets, including Mars. So Mars would have been closer to the Sun in the early days of the solar system, increasing the probability that life could have evolved there. Okay, now I think my theory of gravity, and that is that gravity is due to ether destruction, explains the expansion of the universe. What I think is going on is that the ether is being gradually destroyed and is not being replaced. So the density of the ether is gradually falling. So the acceleration of the ether into bodies, objects like the Sun or the Moon or anything else, is slowly decreasing. Remember, when the Earth is orbiting the Sun, it's held there. There's a force which is accelerating ether moving into the Sun, and then you've got the centrifugal force, which is a force trying to throw the Earth away from the Sun, and that force is given by the equation v squared over r, v being the velocity of the Earth around the Sun, and r is the radius. So you've got a balance there. So if you decrease the pressure of the ether by destroying ether, then the ether will gradually get less and less, and the sun will fling the earth away from it, and then the earth will gradually move away from the sun. So what I think is that we can't see the whole universe. We can only see to a distance of about 13 billion light years. And beyond that, there's probably a huge amount of more universe which we can't see. And I think it's probably a big centre, like the galactic centre, and all the galaxies are in orbit around that galactic centre. And we can only see a small little piece, which is 15 billion light years or so, 13 billion light years or so. So that's why we'll never be able to see the centre of the universe or anything else besides what we can see now. So my prediction is that, if I'm correct, you'll see two things. As the telescopes get bigger and bigger and bigger, the space between the galaxies that you can see in the distance will get larger and larger, and the black background will get blacker and blacker, and eventually you'll see really big telescopes. You'll be able to point to areas where you'll see nothing at all, because everything in those areas is moving away faster than light. That's the one prediction. The second is that one area of our visible universe will be receding at a faster rate than other areas, because one area will be closer to the centre of the universe than the other area, and the area which is further away will be accelerating faster. So the acceleration of the galaxies away from each other will be uneven. It won't be an even distribution. One part of our visible universe will be moving faster than other parts. So those are predictions I'm making, if my theory of gravity is correct. That's what you would eventually find. I just want to discuss a little bit about orbits, because this causes a lot of confusion. In 1957, when I was 8 years old, the Russians launched the Sputnik satellite into orbit. And this caused a lot of consternation, because nobody realized how far ahead Russia was, compared to America in the space race. And when it happened, nobody knew what a satellite was. I remember asking my father, what is a satellite? Because he was a source of all knowledge, he should know. And I was quite surprised when he said he didn't know what it was. Then next day when I went to school, everybody was asking the teachers, what is a satellite? And they didn't really know either. And one of them finally said, it's like the moon, it's just a little bit smaller. And anyway, when I was in the final year at school, we had lectures about orbits. And they said, just think of it as a cannonball. If you fire the cannon fast enough, the cannonball will go over the horizon and it'll start to fall, but because it's going so fast, it'll carry on falling forever. So it's a cannonball falling forever. That was the explanation. But of course later I realised that can't be so simple, because it's breaking Newton's first law. That is, the objects will carry on moving in a straight line unless an external force acts on it. And they never taught us about external forces. So then the external force is actually gravity. And I started doing some calculations to work out how powerful that has to be. To keep the Sputnik satellite, which was 27 pounds, in orbit would require 4 megawatts of power, which is about the same power as you get from a big diesel electric locomotive. So to keep an object like the moon in orbit around the Earth requires an immense amount of power. And that power is coming from the destruction of ether within the Earth. So the solar system and the rest of the universe works by the destruction of ether. We generate power on Earth by shoveling coal into power stations. The universe generates its power by destroying ether. That's my theory. Okay, the next point I want to mention is escape velocity, which is also very confusing for a lot of people, because gravity is an acceleration, so you would expect to escape with an acceleration, but they talk about escape velocity. Okay, the reason for that is that there's a formula which is acceleration equals v squared over r. Remember, you've got a balance. You've got a centripetal force pushing you onto the Earth, and you've got centrifugal force flinging you out. So as the Earth goes round the Sun, there's centrifugal force which is throwing you out. So if you take that equation, A equals v squared over r, and you plug in the values, A is 9.8, the radius of the Earth is 3,641 kilometers, and then you can solve it for V. And when you solve that simple equation for V, you'll come up with an answer of 11.3 kilometers per second. So that is the escape velocity. Once you're going at that speed, according to that equation, you'll have an acceleration of 9.8 meters per second squared. So that'll balance you out completely with the gravitational acceleration, so you'll then be in orbit. That's what escape velocity basically is. If you had enough power, you could just go straight out without having to worry about going into orbit. You could just accelerate upwards and you'd be out into space, like you see in science fiction movies. Okay, the next thing to mention is that you notice the equation A equals V squared over R has got nothing to do with mass. Well, we expect that because, as Galileo showed, the mass is irrelevant to the speed an object falls. It all falls at the same speed. So the outcome of this is that you, if at a certain distance from the Sun, if you're in orbit, for instance where the orbit of the Earth is, you can put anything into that orbit, a marble or a planet the size of Jupiter, and it will orbit at in the same fashion. So that's why in distant solar systems they're finding these large planets, which they call hot Jupiters, which are size of Jupiter or even bigger, which are orbiting very close to the surface of the suns, where they're finding these things. We don't see that in our solar system, but it's perfectly possible that you could have a planet the size of Jupiter orbiting in the same as Mercury, because the A equals V squared over R, mass doesn't matter in that equation. Okay, let me just talk about the Big Bang Theory and the age of the universe. The current accepted model is the universe was created in one explosive point in time, when the whole universe was created from one tiny speck. It was a massive explosion and the whole universe was created. The first problem with that is that if the speed of light is a constant, how can the universe get so big so quickly? Well, the answer is that there was no ether at that time. So if there's no ether, then there's no limit to the speed that any object can move. So it could move billions of times faster than light, because the speed of light wasn't a constant at that stage. And everything just exploded and the whole universe was filled in a millionth of a second because there was no speed limit. Only afterwards, when the pressure of the ether equilibrated throughout the universe, was there the speed of light a constant, and then that could never have happened. So in the initial period there was no ether, so that suggests that the ether was created at the same time the rest of the universe was created. So that can explain the rapid expansion of the universe. Right. The next query which people have got is the age of the universe. Well, they've tried to work out the age of the universe from distances which can be seen with telescopes, and that works out to about 14 billion years, and they've used Hubble's constants and that type of thing to work that out. But there is a problem. If you look at the Hubble deep field, you can see very, very distant galaxies, and they seem to be perfectly formed. Now, the Hubble deep field pictures were taken in the 1990s, and what they did was they took an area of empty space where there didn't appear to be any stars at all, absolutely nothing. And this is about the size of if you take the size of a tennis ball and look at it from 100 yards away, that is the area of space which the Hubble telescope was examining. So tennis ball at 100 yards away. So it was a tiny, tiny piece of space which they were looking at. And when they finished taking this picture, they saw thousands of galaxies there. And it's absolutely mind-blowing. If you haven't seen this picture, you should really study it carefully. So I took a magnifying glass to it and checked it out. And even the tiniest specks that you can see there appear to be perfectly formed galaxies. So that raises a question. How can these galaxies be so well formed if they're only 2 billion years old? Because that's what they say. If you look at the distances and the age of the universe, they're about 2 billion years old. Now our sun is 4.5 billion years old. So how can you have a perfectly formed galaxy which is half the age of our sun? That's the first problem that I've got. The second problem is that giant elliptical galaxies exist, which are large numbers of galaxies which are fused together to form a giant elliptical galaxy. So surely this must have taken much longer than 14 billion years to get all these galaxies to form and interfuse together to form a giant elliptical galaxy. That also seemed to be a bit strange. So maybe the Big Bang is correct, but the time period is wrong. That's a possibility. But anyway, have a look at the deep field picture. Take a magnifying glass and you'll see what I see, that there's well-formed galaxies. Even the tiniest specks seem to be well-formed galaxies. I mean, seeing is believing. Well, I can't believe I actually said that. Now imagine if you were on a planet or one of these very distant galaxies, say 12 billion light years away, and you're standing on that planet, on that galaxy, looking with a Hubble telescope, and you look back and you see our galaxy, which is a tiny little speck far away in a deep field picture. And you'll say, wow, that's the edge of the universe. And then you look on the other direction, and it's also full of galaxies, the same amount, also going back 12 billion light years. Now you're talking about 24 billion light years across in diameter. They've got a 24 billion light diameter, and we've got a 24 billion light year diameter. So you can see the problem is already more than 12 billion years. It's got to be at least 24. Otherwise, the guys on that distant galaxy will be looking on the one side, they'll see absolutely nothing. The other side, they'll see the universe. It just doesn't make sense. So, every time we try to put ourselves at the center of the galaxy or the center of the solar system or the center of anything, it's never been correct. And I think the same thing applies now. That we're certainly not at the center of the universe. So, but as far as the Big Bang is concerned, most nuclear physicists and those clever guys who do this type of stuff think that it is correct, and that explains the formation of subatomic particles and stuff. So we have to accept that the Big Bang probably is correct. It's just the time period could be wrong. Another problem is the presence of quasars, which are very highly energetic objects, which are very, very far away. And, they're only seen at great distances, which would suggest that they were only present in the early days of the universe. That would suggest that 14 billion years is the correct age of the universe. But there is one possibility, is that these quasars are so dangerous that if they were closer to us, they would have killed all life. We wouldn't exist. And that's why the only place we can see the quasars is at great distances. That's a possibility. Right, let me talk about dark matter. This is one of the hot topics in astronomy today. When you look at the galaxies in the visible universe, and you use Newton's equations to work out the mass of these galaxies, there appears to be missing mass. There should be much more mass than we can actually see by looking at the galaxies. So there's they reckon about 95% of the mass in the universe is not visible. A better name than dark matter would be transparent matter, which I saw on TV. And I think that's correct, because when you look at galaxies through telescopes, you see bands of dark matter dust. That dust is not dark matter. That's probably mostly molecular hydrogen waiting to be turned into stars. But what they're talking about is matter which is present. You can see it on the gravitational effect, but you can't see it visually. And that's what they're talking about when they talk about transparent or dark matter. So there's no real theory to explain what it is at the moment. I have my own theory, and my theory is quite simple, that most stars that have ever existed in the universe are actually dead. Now, in the early stages of the universe, there were giant stars, much bigger than we have today. And the bigger the star is, the shorter the lifespan. So a really large blue star, really hot star, might only exist for a million years, whereas our sun has got billions of years lifespan. So in the early stage of the universe, there were probably a lot of these big hot stars which had very short lifespans. But stars, when they blow up or come to the end of their life, they don't disappear. Most of the thing you see when a star blows up is the gas from the outer shells of the star. But the actual bulk of the star condenses into the center and it becomes a very, very dense thing. It can be a neutron star or pulsars, a lot of different things it can be. But the bottom line is the stars don't disappear. They're still there. And then eventually they cool down and you can't see them anymore. And I think that's what the origin of dark matter is. It's stars which did exist which died out billions and billions of years ago, which are still hanging around. They're still in orbits around the galaxies, and there may have been stars which were thrown out of the galaxies for one other reason, and they're still there. But because they are so small, the centers are so small, you know, about the diameter of the Earth or less, that you can't actually see them, and they're not putting out light. So, but their gravitational effect is very big. Whatever dark matter is, it's got to have a big gravitational effect. Otherwise, they wouldn't have noticed this phenomenon. That's my theory. It could well be wrong. But dark energy, on the other hand, is a different thing. The dark energy arises from Hubble's law. The universe is expanding, and not only is expanding, but the acceleration is increasing, so it's expanding faster and faster all the time. So to cause this, there must be a source of energy. So that's what dark energy is. What is causing the expansion of the universe? Well, my theory is that the expansion of the universe is due to the fact that the ether is being consumed. As more and more ether is consumed and is not being replaced, the ether density gets less and less, and the planets, the solar system and the galaxy, everything expands. And that's what dark energy is, the expansion of the universe due to the destruction of ether. Another thing which I wish to mention is the time dilation. Now, Einstein's equations show that as gravity gets weaker, time goes faster. Okay, and people didn't believe this, of course. Nobody believed it until they actually had atomic clocks which were accurate enough to measure this. And today the atomic clocks can measure 10 to the minus 16th of a second, which is really incredible. And they're getting even better than that. So they are so good today that you can take an atomic clock, put it on the floor and get a reading, and then lift it and put it on top of your desk, and you get a different reading. So the clocks tick faster in a weaker gravitational field, just as predicted by Einstein. That's great. But why does this happen? I think the reason why that happens is basically because of the density of the ether. Now, these atomic clocks, the atoms are vibrating, but they're not vibrating into nothing. They're vibrating in the ether. And remember that your gravitational field is due to a difference in the density or the pressure of the ether. Now, in space far away from Earth, the ether pressure is higher. On the surface of the Earth it's low because it's being destroyed in the Earth. So it's moving into the Earth because there's a higher pressure outside than inside. So it funnels down into the Earth. So when you put your atomic clock away from the Earth, for instance, in a geostationary orbit, the pressure of the ether there is higher than it is on Earth here. So those atoms are not vibrating into nothing, they're vibrating in the ether. And I propose that what's happening is that when the ether density is higher, the atoms are vibrating faster. And that's why you're actually getting a time difference. That's the real reason. Okay, so in summary, the force of gravity is actually due to an ether acceleration or an ether drag. And that ether acceleration is caused by the fact that ether is being destroyed in all matter, including the Earth. So you are pushed onto the Earth by the ether accelerating into the Earth. And the second thing is that the ether causes other phenomena, such as the optical phenomena we can see, refraction, diffraction, color. All of those optical phenomena are due to the compression wave which surrounds photons as they move through the ether. So there was a lot of confusion in the early days about waves and particles. What is light? Is it a wave or is it a particle? The answer is it is a particle traveling through the ether and causing a compression wave around the particle. That compression wave doesn't travel very far from the particle before it loses its power, because it's a compression wave and it's dispersing. But nevertheless, it does have these important effects causing all the optical phenomena. I just want to discuss Newton's laws with respect to the ether. So Newton's first law is that an object will carry on moving in a straight line unless an external force acts on it. That's basically because an atomic particle travelling through the ether pushes the ether out from in front of it and it comes around behind it. So the net effect is that there's no change in the ether density. So there's an ether compression, but it pretty soon comes back to where it was. Now some people may say, well, if you've got a stream of photons, won't the travelling of the one photon affect the other photon? For instance, a jumbo jet, when it takes off, it has to be 5 kilometers behind the previous jumbo jet. Otherwise, the air turbulence can affect the flight of the other one. Does that not happen with photons then? If the one photon's pushing the ether out the way, that is going to affect another photon. I don't think so, because they are very far apart. It's like atoms. The distance between them is probably absolutely immense. So, like an atom travelling through the ether, it's not going to affect another atom because the distance between them is absolutely vast. And the ether equilibrates very quickly. So, that's his first law. The second law is basically just a mathematical derivation from the first law, F equals ma. The third law is that every action has an equal and opposite reaction. And the only way you can really explain this third law is with the presence of the ether. Let's take a rocket in space. The rocket accelerates by generating a burning gas, and that burning gas pushes out into space and the rocket goes forward. So the gas goes out the one direction and the rocket goes in the other direction. Why is that? It's because the gases are not just going into space, they're going into the ether. And it causes the ether to compress, and that compression moves all the way around, and eventually that causes the rocket to move in the opposite direction. If there was no ether compression, there would be no movement. The gases would just disappear off into space and nothing would happen. The rocket would stay where it was. It's only because of the presence of the ether that the rocket actually moves. So Newton's third law can be explained by the presence of the ether. Okay, in conclusion, I thank you all for looking at this video. I'm sure of one thing, and that is that other people have thought of the same thing as I've thought of. There's millions of scientists, and that somebody must have had the same idea as this. But I learned one thing from Donald Trump, and that is don't be shy. Just get your theory out there, even if it's wrong, it doesn't matter. At the moment now, we're living in a very unusual time in history. You can publish anything you want and nobody's censoring it. The internet has allowed this to happen. Make the most of it, because this is not always going to be the case. Some bright spark somewhere is going to get an idea that it's a great idea to censor the internet, and your opportunity to publish your gravity theory will be gone. So do it now.